Okay. Okay, so there was a request yesterday to see some of this stuff in practice. So we'll do finding the derivatives of the inverses for a couple practice problems, and then you'll have work time like always. A first step, you need to figure out, your x and y. Right here, this is telling us that we're finding f inverse prime of 2. It's x in the inverse, but since inverse means opposite, in the original function it's going to be the y. So we're going to need to find the y in the original function. So we'll do 2 equals the square root of x minus 2 and solve for x. We'll square, we get 4 equals x minus 2, so x equals 6. So the point that we're talking about is the point 6, 2, but in the inverse, it's the point 2, 6. Well, there's a couple ways we've talked about doing this. One way is to take the derivative of our function, and this is probably the easiest way. It doesn't show as much or explain as much, but it's pretty quick. So we'll take the derivative of our inverse. This one uses the chain rule, so 1/2 times x minus 2 to the negative 1/2 times the derivative of what's inside. We'll clean this up just a bit. So that's 1 over 2 square root of x minus 2. And now we're going to plug in the 6. Plug in the 6 so you know our x value. F prime of 6 equals 1 over 2 square root of 6 minus 2. That's 4. Square root of 4 is 2. So we got 1 over 2 times 2 is 1/4. So that's the derivative of the function. And then the derivative of the inverse at that reflected point, so that'll be 2, will be the reciprocal of that. So that'll be 4. The second one, same thing. Same thing. We need to figure out what the appropriate x and y values is. This is x in the inverse, so that means it's y in the function. So we'll take negative y equals 1 over 27 times x to the 5th plus 2x to the 3rd. And we will do some trial and error. I'm going to create a table, figure out what the corresponding x value is. So we will go 1 over 27 times x to the 5th plus 2x cubed This thing does not want to cooperate. To x cubed and we'll do some plug and chug and see until we get negative 1 over 11. Use the table. Negative 1 over 11, or negative 11, sorry. Negative 11, if we continue to move up. We're going to look at the table until we find negative 11. So when x is 3, y is negative 11. So that's the point. Negative 3, negative 11. So that means in the inverse it's negative 11, 3. Right, so we'll go through, we're going to find the derivative of our function. So it'll be 1/27 times 5x to the 4th plus 6x squared. First derivative of the second, second derivative of the first, because it's a product. The first function is a constant, so the derivative of constant is 0. Let's do f prime of negative 3 then. So we got 1 over 27. Negative 3 to the 4th would be 81. 5 times 81 plus 6 times 9. So 5 times 81 plus 6 times 9 divided by 27 is 17. So that's f prime of negative 3. So then f inverse prime of the reflected point, negative 11, will be the reciprocal of that, negative 1 over 17. All right, looking ahead to the next one. F of x equals x plus 6 over x minus 2. We need to find the corresponding x and y value. We have it for the inverse, the x, so that's the y for the function. 3 equals x plus 6 over x minus 2. This one probably be all right to do a plug and chug. If I plug in 3, I get 3 plus 6 over 3 minus 2. That's 9 over 1. That's too big. So x is not equal to 3. Let's try if we plug in, we can't plug in 2. Let's try if we plug in 4. 4 plus 6 is 10. 4 minus 2 is 5. 10 over 5 is 2. So when x is 4, y is 2. So we've crossed it, so we know it's between 3 and 4. Let's use a table to kind of get a better, or a graph to get a better estimate. So we got x plus 6 divided by x minus 2. And we'll graph that, and 3 as well. Let's see where they cross. We'll do that in a standard window. Looks like it's way higher. Find our intersection. Looks like it's close to 5. We intersect at 6, 3. Oh, that's my mistake. This is a 2, not a 5. 10 divided by 2, then we get a 5. All right, I'm sure you all caught that ages ago. But 6, 3 is our point. That means in the inverse it's 3, 6. So as we're looking for f inverse of 3, we're going to take the derivative, f prime of x. This is a quotient rule. Bottom, derivative of the top is 1, minus top, to the bottom, over bottom squared. And then we'll plug in our 6, f prime of 6. We got 6 minus 2, which is 4, minus 6 plus 6, which is 12, over 6 minus 2, which is 4 squared. So we got negative 8 over 16 is negative 1/2. So when we go to the inverse, f inverse prime of, now it's 3 because we switched the inverse, is negative 2. Okay, last problem then. This one's a little trick here. We got a second fundamental theorem. We got a function defined with an integral. So let's take a look. We want to find where it's equal to 0. Where is this integral equal to 0? All right. Shouldn't take too much thinking to know how do you have an integral equal to 0. Well, the rectangle has to be of 0 width. So that means if x equals 2, then y equals 0. So the point is 2, 0. So take our derivative here, f prime of x of Second fundamental theorem, we're taking the derivative of the antiderivative, they cancel. So you got 1 over the square root of 1 plus t to the fourth, or x to the fourth, because we switch it over. Our point is 2, so f prime of 2 is 1 over 2 to the fourth is 8. 1 plus 8 is 9, square root of 9 is 3. So that means f inverse prime of 0 is 3. Okay, continue working. Make sure you're working on something, watching a video, or doing your assignment.